So in this case, we're actually creating something called an extract refresh. So an extract refresh is a way of Tableau reaching out to an external database, pulling that data in, and then storing that data in a hyperdatabase. So in this case, you might have an operational database, for example, and Tableau has instructions to reach out to that operational database, perhaps every hour, perhaps every day, perhaps every half an hour, or every month, depending on the schedule that you need. Bring in that data from the external database, store it in an efficient form inside of a hyperdatabase, so that when your users are viewing the dashboard, they might be viewing the dashboard every second, that dashboard is being served by the hyperdatabase. And much less frequently, that hyperdatabase will reach out to your source database and bring in fresh data. As I say, the benefit of doing it this way is that it can be a lot faster if your database isn't optimized for querying, but there could be some delay in actually seeing that data updated. So if you, for example, you update a record in your database, you're not going to see that reflected in Tableau until a short time afterwards when you actually have your extract refresh scheduled. Now, in this particular use case, we're actually relying on a scheduling capability built into Tableau to actually pull data into the hyperdatabase, but we can also trigger this externally. Now, there's a few ways that we can actually trigger this externally. So we can use a command line tool called tab command, which issues commands against the Tableau server instance, telling it to pull fresh data. Or we can use something called the Tableau Server REST API, which is easier to build a more deeper integration with your application. Now, the reason why we might want to do this is that we might want more fine control over when this is going to happen. So say, for example, we have an ETL job that processes data into the external database at 6 a.m. every morning. And takes around 5 minutes. Now, we need to, when that job is complete, we need to actually tell Tableau in order to pull that data into Tableau. Now, Tableau is not able to natively monitor the external state of the application and then trigger that job dynamically. So what we might like to do is rather than saying to Tableau, okay, we want you to guess when this is going to be ready in the source data and perhaps run the job an hour later, we want to actually trigger the ETL job for the database externally, and the second that that's finished, we then want to send a signal to Tableau saying, okay, the source data is ready, you can now pull that information into your hyperdatabase, and that will be ready for the users. This way we can make sure that this is ready a lot quicker. So it might be the case that this takes on average 5 minutes, but immediately when the ETL job is finished, Tableau gets that nice signal saying, okay, pull that information into your hyperdatabase so it's ready for the users. The other benefit of actually using a hyperdatabase is that you might actually have multiple connections to different databases. So perhaps you have an operational database in Postgres that contains your transactional data, but you might have a user database in MySQL that contains your permissions data. In order to actually surface your analytics to your users, you might next need to bring both of those bits of data into Tableau, store that in Tableau, and actually surface that as a single view. Now, obviously, you've got the option of actually doing some transformation process yourself, perhaps copying the data from one database to the other, or staging it in a common location. But in reality, you might not want to do all that work. And actually bringing it all into a hyper database is a good way of getting a really fast time to market for your solution.